Alright, final section in Chapter 3, Section 3.5 is on specific heat. Now, there are several video problems that go over this, and so after you get done with this video, make sure you go on over and check out those video problems. And, you know, as always, if you have questions, you can just email, you can get on the discussion board and post those questions, and I'll get on there and answer them if somebody else doesn't beat me to it. So, you know, ask away. So let's talk about what's called specific heat. So this idea just stems from the fact that objects take different amounts of energy to change their temperature. So think about heating an aluminum pan full of water. So here's the aluminum pan. This will be a better drawing than the last finger that you saw there. So look at that. That's genius. That's an aluminum pan. So we put this aluminum pan, right, and that aluminum pan is full of water right there. And you can actually try this if you want to. Take a pan, fill it full of water, and heat it for, let's say, 1 minute. Right? So you've got it heating for 1 minute. Would you touch the water on the inside of that pan after it's been heating for 1 minute? Yeah, you would, right? It's not that hot, that water isn't. Now, would you touch the side of the pan after it's been heating for 1 minute? No. No, you wouldn't. Now, keep in mind, that's a very thin layer of aluminum there. So it's not like we're talking about, you know, a 1 foot thick chunk of aluminum and then some water on top of it. We're talking about a very thin layer of aluminum and then the water. So the fact is they're both absorbing about the same amount of energy. Yet you can touch the water. You wouldn't want to touch the aluminum pan. Why? Well, it's because of what's called its specific heat, right? So the specific heat capacity is the amount of heat that's required to raise 1 gram of that substance 1 degree Celsius. You see how specific that definition is? That's why it's the specific heat capacity. The heat capacity is the amount of heat required to raise a substance 1 degree Celsius. So let's say we got this big chunk of granite or something like that, right? We got this big chunk. We could see how much energy it takes to heat that up 1 degree Celsius, and that would be the heat capacity. The specific heat capacity is for 1 gram of this substance. So if we cut some of that off, that would be for 1 gram of that substance. Now, this is a physical characteristic for sure. We can often determine the type of substance we have by looking at its specific heat capacity, and that's actually what you're going to do in your lab. So in your lab, you're going to get an unknown chunk of metal. So here you go. You're going to get this unknown chunk of metal, and then you're going to heat this up. So you're going to put in a defined amount of energy. So you're going to know the temperature that it is. That's Bunsen burner. And then you're going to put that into a cup of water. Here's water. And you're going to see the change in temperature of the water. We know for sure that water, liquid water, has a specific heat capacity of 4.184. Now, what does that mean? Well, let's blow this up over here. So it's 4.184. Let's look at the units. Joules per gram degrees Celsius. So what that means is that water takes 4.184 joules to heat up 1 gram of water 1 degree Celsius. Okay, so let's take a look at aluminum. Right? So here's aluminum. Aluminum only takes 0.897 joules per gram 1 degree Celsius. Okay. So what if I have right here a 1 gram chunk of aluminum, and I've got a 1 gram volume of water, okay, and I put 1 joule of energy. So I put in 1 joule of energy into the water, and I put in 1 joule of energy into the aluminum. Will they have, and they both start at the same initial temperature. Let's say they both start at 25 degrees Celsius, which is approximately room temperature. Right? So this is aluminum at 25 degrees Celsius, and this is water at 25 degrees Celsius. And I put in 1 joule. Will they have the same final temperature? No. Which one will have the higher temperature? Aluminum. Why? Well, the aluminum, it only takes 0.897 joules to heat 1 gram 1 degree Celsius. So if I put in 1 joule, this will actually go up a little more than 1 degree Celsius, right? Just a little more than 1 degree Celsius. There you go, like that. Greater than 1 degree Celsius. But this one, water takes 4.184 joules to go up 1 degree Celsius if I have 1 gram. So this will be a little less than 0.25 joules, or 0.25 degrees Celsius. So again, the aluminum, since it takes such little amount of energy to heat it up, the aluminum's temperature will go up by more than 1 degree Celsius if I put 1 joule into that 1 gram substance. The water, though, the water takes 4.184 joules to go up 1 degree Celsius if I only have 1 gram of it. So water's temperature will go up less than 1/4 degree Celsius. So that explains why we would touch the water, but we wouldn't touch the aluminum pan. Specific heat capacity. So you can see some specific heat capacities here. Gold has a fairly low specific heat capacity. Let's see, water has huge specific heat capacity, and you'll see that in the lab. You know, ammonia, gas, that's pretty high for a gas. Ethanol, liquid. So you never have to memorize specific heat capacities. You use water a lot, so you'll end up remembering that, but you know. So we can look at this equation for specific heat capacity. Now, just to warn you, your textbook, Timberlake Chemistry, uses SH for specific heat capacity. In AP, we use C. Right? C is specific heat capacity. So just be aware of that. So what is it? Well, I often say it's Q equals MCAT, MC delta T. Okay. So what is Q? Q is the energy. Okay, so that's, in other words, that's the joules. Now that's the energy that we have either lost or gained, and we got to talk about losing and gaining energy here too. M is the mass of that substance, so how much of that substance is heating up, and that's measured in grams. C is the specific heat capacity, okay, and delta T is the change in temperature. Okay, now let's look at a couple of these a little closer here. Let's talk about energy first. Okay, so I'm going to come down here and take a few notes on energy. Now, energy can be lost or gained. Okay. If we lose energy, then energy is negative. If we gain energy, energy is positive. We have increased our energy if we gain it. We have decreased our energy if we lose it. So energy can either be gained or lost. Right. M is the mass, C is the specific heat capacity of that substance. Now delta T, and you should know this, but I'll just remind you, delta is always final minus initial. There's only one instance where it's not. You'll learn about that in AP Chemistry. But delta is always, almost, final minus initial. Now, a change in temperature of degrees Celsius is equal to a change in temperature of Kelvin. So if it goes up 5 degrees Celsius, it's also going to go up 5 Kelvin. So if you're given the temperature in Kelvin, use it. If you're given the temperature in Celsius, use it. If you're given the temperature in Fahrenheit, throw it back in their face, tell them I'm not doing this. No, I won't give you any Fahrenheit. So, okay? So I think when you look at those video problems, that'll help you out too. So, and that's the end of chapter 3. Almost there, man. Almost there.